part 2 for our Unit 5 review. I'm going to start with question 14. This is where we left off after part 1, and I'm going to try my best to make it to question 31. Okay? All right, so this says, what are the values of k for which the integral from -3 to k of x squared dx equals 0? So this is actually one of the properties that you would have seen in, I think, our second lesson. Let's see if I can find it here. Yes. All right, so one of the properties from our second lesson states that if your integral has the limits of integration that are the same, so this one right here, if your limits of integration are both the same number, then it's always going to be equal to 0. So when I look at answering this question for number 14, all right, I have my lower limit of integration is -3. So for this to be equal to 0, this also needs to be -3. So that's why 14 is A. All right, 15. All right, it wants us to find the integral from 2 to x of 3t squared minus 1. So what I'm going to do is I'm going to integrate 3t squared minus 1. So the antiderivative of that is going to be, all right, so t cubed would be 3t squared, so that's good, minus t, all right? And then I'm going to plug in x into this. Let me make that f of t, I apologize. So plug in x here, and then plug in 2. So it's going to be x cubed minus x minus 2 cubed minus 2. So x cubed minus x, and then minus, that's 8 minus 2, which is 6. So x cubed minus x minus 6 is letter A. So that's 15. Let's go to 16. All right, so it says that n is a known positive integer for what value of k from the integral from 1 to k of this function is it the same as 1 over n. So the way I actually did this problem was I picked a value for n. So I just chose n is 3. So I did the integral from 1 to k of x to the second power, right? 3 minus 1 is 2 dx, and that's equal to 1 over 3. So the integral of x squared, the antiderivative, is going to be 1/3 x cubed. And I'm going to evaluate this at k and then at 1. All right, so I'm going to have 1/3 times k cubed minus 1/3 times 1 cubed, and that's equal to 1/3. So that's 1/3 k cubed minus 1/3 equals 1/3. If I factor out the 1/3, I get k cubed minus 1. If I move the 1/3 over with multiplication, I get k cubed minus 1 equals 1, right? 1/3 times 3 is 1. Move that minus 1 over, you get 2. So k equals the cube root of 2. All right, now another way to write this, as I said before, was 2 to the 1/3 power. And if you remember from the very beginning, the very first thing I said that I was going to do was I was going to use n is 3. So if you write this, for the answer choice, it's going to be 2 to the 1 over n power, which is D. So that's 16. Let's try 17. All right, 17 says if you have g of x function and f of x equals the derivative of that g of x function, if you want to do the integral from 1 to 3 of that f of x function, all right, so going backwards, you could write it like this if it helps your brain. F of x is the same as g prime of x. And you guys learned from the fundamental theorem of calculus part 1 that the integral and the derivative are inverse operations. So if you're finding an integral of a derivative, then your integral for that is just going to be g of x. So if I do g of 3 minus g of 1, right, this is my antiderivative. If I find g of 3 and g of 1 and subtract, I will get the answer. So that's going to be 3 squared minus 3 times 3 plus 4, so whatever that is, minus 1 squared minus 3 times 1 plus 4. All right, so whatever that is will give us our value here. 3 squared is 9. 9 minus 9 is 0, so that's 4. And then minus, that's going to be 1 minus 3, which is -2, plus 4 is 2. So 4 minus 2 is positive 2. Okay, let's go to 18. All right, another definite integral here. So I'm going to do the antiderivative. which is going to be, let's see, x to the fourth power. But I want it to be 8x cubed, not 4x cubed. So if I put a 2 there, that would be 4 times 2 is 8x cubed. And then this one is going to be x cubed. If I take the derivative of x cubed, I get 3x squared. So that one's good. All right, so I'm going to evaluate this at 1 and negative 2. So f of 1 minus f of negative 2. So 2 times 1 to the fourth power minus 1 cubed minus all of that minus 2 times negative 2 to the fourth power minus negative 2 cubed. So that's going to be 2 minus 1, which is 1. Negative 2 to the fourth power is 16 times 2 is 32. Minus, let's see, a negative 8, which is really going to be addition. So 1 minus 40, which is, excuse me, negative 39. There's 18. Okay, 19. All right, we talked about this again with our fundamental theorem of calculus part 1, but if you take the derivative of an integral, right, those are inverse operations. So the only thing you have to do here is to replace this t cubed with that x squared. So I'm going to write the sine of x squared and all of that's cubed. All right, so it's going to be sine of x to the 6th power. But here's the problem, guys, and what people are going to, they're going to put C as an answer choice, but you're not going to, because you also need to do the chain rule of what you plugged in, which is the derivative of x squared. And the derivative of x squared is 2x. So just organizing it the way that they want, the answer is going to be E, 2x times the sine of x to the 6th power. Let's go to 20. All right, 20 says if f prime of x is 3x squared plus 2x, and f of 2 is 3, and then what is f of 1? So this is actually going to be finding an integral of 3x squared plus 2x. So I'm going to find the antiderivative. So I'm going to write x cubed. Taking the derivative of x cubed would give me 3x squared, so that's good. And then if I write x squared, the derivative of x squared would be 2x. So we're good there. All right, but here's the deal. Normally I don't write plus c, but it's telling me to evaluate this original function, the f of 1. So I am going to use this information here that if I were to plug in 2 to this function, so 2 cubed plus 2 squared plus c, I would get 3. So I'm going to solve for c. So that's 8 plus 4 is 12 plus c equals 3. So c equals negative 9. So now my f of x function is x cubed plus x squared minus 9, and I'm plugging in 1. So 1 cubed plus 1 squared minus 9. So 1 plus 1 is 2. 2 minus 9 is negative 7. So 20 is B. All right, let's go to 21. All right, so this is the integral from 0 to x of sine t dt. So what I'm going to do is I'm going to find the integral of sine. All right, and I know that the derivative of cosine would be sine, but that's a negative sign. So I actually have to put a negative in front here. And then I'm going to evaluate this at x and at 0. So I have the opposite of the cosine of x minus the opposite of the cosine of 0. So this just becomes negative cosine x. Now watch what happens here. Cosine of 0, right, if you do your quadrantals again, that's going to be cosine of 0 is 1. So the opposite of 1 is negative 1. Subtracting a negative makes that addition. So that's my answer. If you notice, I don't have that except for question D, or answer choice D. You can rearrange this to be 1 minus cosine x. All right? Or hold on a second. Anyway, that was really funny. I'm sorry. I just didn't even have answer choice E available, so I was only looking at A through D, which was why I was confused, why I couldn't find this. But there it is. Answer choice E was hiding. So it's 1 minus cosine x. I was like, I swear I did this right. So I apologize for that. 21 is E. Okay, 22. All right, 22 wants the integral of sine. We just did that, right? We just found that antiderivative to be negative cosine of x. And I'm going to evaluate this at pi over 4 and at 0. So negative cosine of pi over 4 minus negative cosine of 0. We just found the cosine of 0, All right, so let's find the cosine of pi over 4. That's the square root of 2 over 2. And then minus the cosine of 0 is 1. So the opposite of 1 is negative 1. You're going to add that eventually. So add 1. So the answer is going to be D. Let's go to 23. Okay, now 23 gives us a lot of information about x, or about the f of x function and the derivative. And we want to find the value from 0 to 3 of f prime of x dx. So remember, the integral of a derivative is just the beginning f of x function. And we want to evaluate this at 3 and 0. So if I do f of 3 minus f of 0, I will get my answer. Well, in the table, f of 3 is 10. And f of 0 is 4. So when you subtract that, you get 6. All right, let's try this one. The integral from 1 to 2 of 4x cubed minus x. So let's do the antiderivative. I'm going to start with x to the 4th power. The derivative of x to the 4th power is 4x cubed, so that's good. Then I have x squared, right? But the derivative of x squared is 2x, not just x, so I have to put 1/2 in front to make that just 1x when you take the derivative. And I'm evaluating this at 2 and 1. So f of 2 minus f of 1. So that's 2 to the 4th power minus 1/2 times 2 squared. All of that minus 1 to the 4th power minus 1/2 times 1 squared. All right, so that's 16 minus, let's see, 2 squared is 4, half of 4 is 2, minus 1 minus 1/2, which is 1/2. So I have 14 minus 1/2, so the answer is 13 and 1/2. And if you notice, you don't have that as an answer choice, but answer choice A, when you divide 27 divided by 2, is 13 and 1/2. Okay, 25. Now, we did a problem just like this, actually in class today on this date, January 13th, about the finding how much gas is being used on a motor on a motorboat for 1 hour. So this is a very similar problem. It's asking us to find the amount of snow in inches that falls from 0 to 5 hours. All right, so the function is 2e. I know it's hard to see, but that's negative 0.1 to the power of t. Now, what I want to show you guys is, at this point, when you're in this point that I'm making this video, you haven't done this yet, but you will next week, where we're going to find the integral of exponential functions. But I'm just going to go with your understanding of from last semester. And last semester, if I wrote e to the negative 0.1 t power, right, if you wanted to take the derivative of that, you just copy it. So you copy e to the negative 0.1 t power, which we have, and then you multiply it by the derivative of the exponent. And the derivative of negative 0.1 t, is negative 0.1. But I don't have negative 0.1 there. I have negative 2. So I actually need to multiply this by negative 20. And if I evaluate this at 5 and 0, I will have my answer. So negative 20 times e to the negative 0.1 times 5 minus negative 20 times e to the negative 0.1 times 0. So this one is just going to be e to the negative 0.5 power. And then watch what happens here. E to the 0 power is just 1. All right, negative 20 times 1 is negative 20, but you're subtracting negative 20, so it becomes addition. So if you look here, you don't see it. You may not see it, but if you change the order again, it's going to be letter D, 20 minus 20e to the negative 0.5 power. So 25 is D. Okay, 26. All right, it says, at t equals 0, a particle starts at rest and moves along a line in such a way that at time t, its acceleration is 24t squared feet per second, right? Per second squared. Through how many feet does the particle move during the first 2 seconds? So this is actually going to be twice we need to integrate this, right? Because if you remember from last semester, I told you position, then velocity, and then the acceleration functions, right? So right now we're at this step, and we've got to back up twice. So what I'm going to do is I'm going to find the integral of 24 t squared dt, right, which is going to be, let's see, that's t cubed. It needs to be 8. 8 times 3 is 24. Then I'm going to do that again and that's going to be t to the 4th power. And then I want this to be 8, so 2. So this right here is my position function here. So now when it says, how many feet does the particle move during the first 2 seconds? I'm going to evaluate this at 2 and 0. All right, so 2 times 2 to the 4th power should give me my answer, because 0 to the 4th power is just going to be 0. So that's 16 times 2, which is 32. Okay. All right, this is, I think, the hardest problem, all right, because we're given a velocity function and it wants to find the total distance. And this is the problem that we actually just finished in class today on the 13th. But essentially, what I'm going to be doing, since I'm finding the total distance, all right, I don't care about where it's positive or negative. I have to add all the areas together. So I'm looking from 0 to 3, and I'm going to write down the absolute value here to show you that I'm going to be talking about adding whether the area is negative or positive. So let me graph this for you so you can see what I'm actually talking about. All right, so t squared minus 6t plus 8. So it's going to be x squared minus 6x plus 8. All right, I'm graphing it from 0 to 3. Okay, so here it is. And if you look, from 0 until 2, we have positive y values. But then from 2 to 3, we have negative y values. But again, because I want the total distance traveled, I don't actually care that there's a little bit negative. I'm going to be adding both of these together. But just like we talked about in class, I need to set up two integrals where one is from 0 to 2 and the other is from 2 to 3. Okay. Now, if you're, I think it was Natalie that asked, how can you know this without the graph? If you set the, let's plug in 0 to t squared minus 6t plus 8, you get 0, 8. And if you plug in 3, let's see, that's 9 minus 18, negative 9 plus 8 is negative 1. So you'll notice we have a positive y value to a negative. So somewhere in between here, we are crossing the x-axis. So I'm going to set t squared minus 6t plus 8 equals 0. This is factoring t minus 4 times t plus 2. That's not right. Is that going to be right? Nope. They both got to be the same. T minus 4 and t minus 2. Excuse that algebra brain fart there. Sorry about that. So we have two answers. T is 4 and t is 2. Again, the only one I care about is 2 because my interval is between 0 and 3. So that's why I don't care about the 4. All right, so I'm setting up two integrals. One is 0 to 2, and the other is 2 to 3. Now, if you notice in the graph, the first one, 0 to 2, is the positive one. So I just copy that down what I had before, t squared minus 6t plus 8 dt. But the second one, if you look on the graph, is the one that has negative, right here, negative y values. So I'm going to change them to be the opposite. So the opposite of t squared is negative t squared. Opposite of negative 6t is plus 6t. And the opposite of 8 is negative 8. All right, so let's integrate this. So let's see, we have t cubed, so 1/3 t cubed. This is going to be t squared minus 3t squared plus 8t, and evaluating that at 2 and 0. And then whatever I get there, plus this integral is going to be negative 1/3 t cubed plus 3t squared minus 8t, and I'm evaluating that at 3 and 2. So there's a lot of work to do here, all right? And essentially, I'm just going to kind of write out my work and then go to Desmos to find the actual numbers. So I have 1/3 times 2 cubed minus 3 times 2 squared plus 8 times 2. I'm not going to plug in 0 because all of that would just be 0. So this gives me my first piece. And then I'm going to do negative 1/3 times 3 cubed plus 3 times 3 squared minus 8 times 3. All of that minus negative 1/3 times 2 cubed plus 3 times 2 squared minus 8 times 2. So all of that will give me my second piece. So let's see if I can get Desmos involved here to find the answer. All right, so I'm going to start with 1/3. Let me move this over here. So 1/3 times 2 cubed. And then it says minus 3 times 2 squared. And then I think it's plus 8 times 2. Let me confirm. Plus 8. Yes. Okay, so that's the first piece. Here's all the second piece I'm going to add to that first piece. So negative 1/3 times 3 cubed plus 3 times 3 squared minus 8 times 3, whatever that is, minus negative 1/3 times 2 cubed plus 3 times 2 squared minus 8 times 2, right? So if I add these together, that's 20 thirds plus 2 thirds, which is 22 thirds. So my answer is 22 thirds, which is D. Again, I think that's probably the most challenging problem of this entire review or units. So 27 is D. Okay, we're almost there. Remember, I'm going to go until 31, I think, on this part. And then we'll be moving into part 3. So let's try 28. We have the rate at which people arrive at a theater box office is modeled by this function. All right, it's going from 0 to 20. And it says, which of the following is the closest number of people that arrive at the box office during the time interval 0 to 20? So essentially what you're doing is 0 to 20 of your function. All right, and if you do this, you're just finding the area under the curve. So what I did to break this up was I did a trapezoid. All right, so this trapezoid here, found that area, and then this triangle, and found that area. So the trapezoid one is going to be 1/2 times 15 times my bases, 5 plus 15. All right, so that's going to be 1/2 times 15 times 20. Half of 20 is 10. 10 times 15 is 150. So 150 is that number. And then finding the area of that triangle, that's going to be 1/2 times 5 times the height of 15. So that's going to be 75 halves, which is, let's see, 37.5, I believe. All right, so when you add this together, you get 187.5. 187.5. If you look, you don't have that, but it says which of the following is closest to the number of people. So it's 188 is closest to 187.5. Okay, let's go to the next one. We have a particle moving along the x-axis given by the velocity function sine of 2t. If the position of the particle at time t is pi over 2 and its x equals 4, where is the particle's position at t equals 0? So what I'm going to do here is I'm going to find the integral of my velocity function, which is the sine of 2t dt. So the integral of that would be cosine. But again, the derivative of cosine is negative sine, so I need a negative out front. And you'll notice there's nothing in front. And when we do the chain rule, I would get a 2. So I have to do 1/2 to get rid of that. So this is it. But we have some constant, and it says when you plug in, let's see, what does it say? When you plug in time is pi over 2, right? So if I make this negative 1/2 cosine of 2 times pi over 2 plus c, your particle is at x equals 4. All right, well, the cosine of pi, right, is going to be negative 1. So negative 1/2 times negative 1 is positive 1/2. So c is going to be equal to 3.5. So now when it says, what is the particle's position at time t equals 0? I'm going to do negative 1/2 times cosine of 2 times 0 plus 3.5. Whatever that is will give me my answer. Cosine of 0 is 1. That's a negative 1/2 plus 3.5. So the answer is going to be 3. So 29 is C. Okay, number 30. Number 30, very similar type problem. All right, it says, which of the following gives the total distance the particle travels from time t equals 0 to 3 pi? All right, the key thing here is they're trying to mislead you with this information about the initial position. That's not necessary to answer this, because essentially when I see that total distance, I'm thinking absolute value. So the only one that makes sense here is the integral from 0 to 3 pi, the absolute value of that sine t. All right, because again, I might have some that's below the y-axis, some above, but I don't care because I got to add them all together to get the total distance. That's the key word here, total distance. Okay, let's do this last one and then I'll be done. All right, so a bug is crawling up a vertical wire at t equals 0, gives us the velocity, and then what is the total distance the bug traveled from 0 to 8? So that'd be the integral from 0 to 8 of this velocity function. So I'm just trying to find the area under the curve. So let's see what I can do here. So we have a triangle, rectangle, another triangle, and then another triangle down here. Now, be careful here, right? It says total distance, okay? So in total distance, you've got some negative velocities there, but we are going to be adding, because it says total distance, we are going to be adding all these areas. So this one is 2 times 3, which is 6, divided by 2 is 3. 2 times 3 is 6. 2 times 3 is 6, divided by 2 is 3. And this is 2 times 1 is 2, divided by 2 is 1. So 3 plus 6 is 9, 9 plus 3 is 12, 12 plus 1 is 13. Okay, so key thing is total distance, we're adding everything, even though we have one of them as negative. All right, that's it for part 2. When we come back on part 3, I'll be moving into some substitution with number 32.